attention that box-M test is very sensitive to sample size. For example, in this data sets, we see that there is 435 female participants and 565, and it means near 100 difference between sample size of two subgroups, and for classes equal and very large difference. We see that for class subgroups 1 means non-diabetics, we have only 103 participants, and for pre-diabetic 53, but for diabetic participants sample size is equal 844, means a large parts of participants have diabetes. And since box-M test is very sensitive to equality of sample size, then it's real and it's rational that equality of occurrence was not assumed. But when we see about equality of variance, we need to go to a part of a report named Levin's test of equality of error variances. And in this table, we see that fortunately, equality of variances is assumed because SIG in cholesterols and LDL based on mean, median, and other measures is more than 5% alpha levels. And finally, I can conclude that we have equality of error variances, but not equality of error covariances. But since we want to continue interpret and check another assumptions, we assume that equality of variance and covariance assumptions is assumed and continue to interpret another tables. Okay, now it's time to check second assumptions of a two-way MANOVA named normal distribution of residuals. In the last tutorials of Amardan, we have educations about one-way ANOVA, two-way ANOVA, one-way MANOVA, and in these tutorials I speak completely about how to check a normal distribution of residual, but now I speak about these assumptions briefly. To do this, you need to first times go to data and split file and uncheck compare groups, or check analyze all cases, do not create groups, and click on OKs. Then go to SPSS datasets, and you see that SPSS added two new columns named RAS1 and 2, and two new columns about Cook's distance named COO1 and 2. But how to check normal distribution of residuals? To do this, you need to go to Analyze menu, click on Descriptive Statistics, click on Explores, and add RAS1 and 2 to this place, and click on Plots, click on Normality Plots with Tests, and click on Histograms to plot histogram plots in your reports. Click on Continue and click on OKs. Then go to SPSS reports. We see that sconus and cortisol residual for cholesterols is a little large, and maybe normal distribution of residuals was not assumed, and also for LDL is large also, and test of normality with Kolmogorov, Smirnov, and Shapiro-Wilks is less than 0.005 and less than 5% alpha level. And now we can conclude that unfortunately residual of these models has not normal distributions, and you can check about this with histograms plots, and we see that it's far from normal distributions, and unfortunately normal distribution of residuals was not assumed. The QQ plot is also say that normal distributions was not assumed. But I can say that multivariate tests was robust to a normal distribution of residual, especially when sample size of groups is equals. And to continue check and review another assumptions and another tables, we assume that normal distribution of residuals is valid, and now we go to another assumptions. Third assumptions is about linear relationships between dependent variables and independent variables separately. How to check this? You can check these assumptions with a table named test of between subjects. Click on these terms, and you can check about these assumptions and these tables. These tables is similar to a regressions. These tables reports about intercepts and every independent variables, for example, gender and class and errors. It's similar to a regression report. In other words, in this part, SPSS fit a linear regressions between every dependent variables with independent variables. For example, so now I can check about cholesterols and linear relationship between genders and cholesterols. Now I can interpret that there is not a linear relationship between genders and cholesterols, but there is a linear relationship and significant relationship between class and cholesterol, since SIG for class is less than 5%. And for LDL dependent variables, there isn't any linear relationship between gender and also class and LDL dependent variables. Then we can conclude that for dependent variables, LDL dependent variables, we have not a linear relationship between genders and also class. But for cholesterol dependent variables, there is a linear relationship between class and cholesterols. Now we go to another assumptions. Okay, now it's time to check about independent observations and also multicollinearity. In two-way MANOVA, since we have two independent variables, it's necessary and vital to check about multicollinearity. To do this, you need to go to Analyze and click on Regressions, click on Linears, and in other words, you need to fit a linear regressions. To do this, you have to click on cholesterols and import these to dependent variables, click on gender and class and import to independent variables, click on statistics, and then click on Durbin-Watson to check about independent observations, click on collinearity diagnostic to check about multicollinearity. Then click on continue and click on OK. Repeat this process for LDL cholesterols, and you need only to replace cholesterols with LDL and then click on OK. Now we see that there is a table named model summary, and in the last columns you see that Durbin-Watson columns added to these tables. Durbin-Watson is an index with value range from 0 to 4, and if you have a value between 1.5 to 2.5, you can assume that there is independent observations. And now we see that independent observation was assumed for our our data sets and also for LDL and also for cholesterols. But for check about multicollinearity, you need to go to a table named coefficients. For multicollinearity, coefficients table reports that amounts of VIF or variance inflation factors for gender and class is near to 1, and when we have a VIF near to 1, we can assume that multicollinearity is valid, and also for LDL dependent variables is okay, and we can conclude that both independent observations and multicollinearity assumptions is valid and was assumed.